The objective of this symposium is synergy, which is putting together these disparate parts. We've heard about reactors and power and propulsion systems and manufacturing systems, from 3D printing to the girders, the tethers, and constructing girders in space. And how does this all come together? Before we begin, I just want to dispose of a couple questions from the audience. First one was any and all. I don't suppose anyone has an opinion on what the new proposed Space Force is supposed to do. That's sort of outside the area of this conference.
We're here for Star Trek. That's Star Wars.
Okay. Thank you for the clarification. We also, this is from the table discussions. We had a question about what is the minimum critical mass of an independent group. How long can it function indefinitely? And the table agreed that basically the question was a little too broad. Are we talking about for months, years, or generations? Because you need a minimum genetic thing. But in that discussion, it got pretty interesting. Are we talking about how long can they survive logistically or culturally? Do they start killing each other? And some various examples of that are the Polynesians, who would go on long canoe trips with, just a few people on the canoes. But in addition to the warriors, they also had lots of women aboard who were selected for the organizational, and also they would tell the stories and keep the lore. And was carrying the civilization with them, basically. You had isolated communities like Easter Island, which wiped itself out, and Pitcairn Island, which survived for several decades, isolated. And then you have Japan, which closed all their borders and were completely isolated for several hundred years. So it was an interesting question, but that is something that we'll be looking forward to perhaps tomorrow in the far future segment that we're going to be addressing. Anyhow, a couple of you have questions that were given to you. Ken?
To what degree have treatment solutions been developed for managing effects? In other words, what kind of drugs do we have, and exercise? What kind of exercises do we have to mitigate, experience with zero G? NASA's working very hard on that. Looking at, what kind of drugs can they give people to, keep the muscle up and the bone mass up. And I think they're making progress on that front. But still, even today, when astronauts, come back, they have problems adapting to 1G. So they're making efforts on that front, but I think they have a ways to go. Number two, if we envision humanity living in space and other bodies, do we need to accept the physical consequences on children, or is there an ethical imperative to keep human physiology intact? Oh, an ethical question.
There's always solid answers to that.
Yeah, there's a number of answers to that. I guess my preference would be to, keep humans pretty much the way they are, because we don't know what happens when we start changing people. But you can argue either side of that it might be worthwhile to modify people to suit conditions. Just, when you start changing people, you start changing their psychology, and there's unintended consequences. And number three, will there be differences when providing 1G head to toe versus front to back? Could sleeping in 1G be sufficient to alleviate the Coriolis effects? As long as your head is stationary and not turning, there's no Coriolis effect problem. Just when you stand up and you turn your head, that's when the issue, rears its head, so to speak.
Thank you, Ken. Now, Jeffrey, you have a question also there?
Yeah. I think this is a really good question. Many new technologies, such as manufacturing, laser beam propulsion, and the reuse of space debris, which is what I'll focus on in the answer, require the change of development of new regulations or practices at the agency, government, and international level. How do we tackle this challenge, and is this necessary? Yes, it's necessary. It's a huge problem. When I've discussed in the past reusing space debris, people pull me aside and say, well, you can't just go take somebody's dead satellite and reuse that material. That's illegal. And I said, well, what if they give you permission? They go, well, what's in it for them? You have to somehow motivate them to sign over responsibility for this, and if it's a foreign government, they're probably going to worry that you're going to understand something about what they did. If it's a U.S. agency of some sort, they tend to be pretty secretive too. It really, it's surprising how little support of your dead satellite. I'd like to go take that and reuse it for something. People have made it clear that that just is not in the games right now. There's work that's been done to change that. There have been people that have tried to say, hey, if you've abandoned it, if it's been dead for so long, then it becomes just debris and anybody can go fix it. But I'm not aware of any progress there.
Sure thing.
It's outside national borders. It's dead. The putative owners have made no effort to reclaim it. It's salvage.
I like that idea,
That's
but I also am a fan of piracy, and I don't have a galleon, but I'll invite some of you if I get one.
Okay.
Dr.
The
Jess-
Outer Space Treaty actually talks to that, and that is every launched thing, whether it's the launch vehicle or payload, has a nation of registry, okay? That never changes. If a satellite is dead, it is still registered to that nation. So what you're saying is correct. Until they divest and transfer ownership, you can go get it, but if they don't agree with it, they have legal recourse against you. So, yes, it is not the same as the law of sea salvage, which a lot of people would like to replicate this after. But right now, that would require a change to the Outer Space Treaty, which I think self-immolation at the same time you're committing ritual seppuku, it comes to mind as to how hard it would be. Just a big deal. I mean, people would like to be able to salvage valuable assets, but you need permission by the owner.
One of the things that we're about to move into theme 3 with the transformative decadal plan, and what I'd like to expand this question about regulatory issues with the theme 1 and theme 2 representatives here on the what sort of challenges are we going to see in the next 10 years? For example, if we're launching nuclear reactors on large chemical fuel rockets, there's going to be people upset about that and protesting. And how is that controlled in regulation? What sort of new regulation for any of the things that we're launching or dealing with?
Well, I can just mention on the nuclear, there is actually high-level discussions going on because, again, with a reactor, there's no uniquely hazardous material on board at launch. And so I think from a logical and really concerned about actual safety, that will be a straightforward process. In other words, protecting the public during that launch. It really comes down to the launch of a reactor is easy to make, no more hazardous than any launch. So it's just launch of any rocket has some hazards. Having a reactor on board, there's no reason for that to change, I guess you would say. But in other words, again, I think the logical approval process will be it'll be very straightforward. Now the public affairs, the public relations, the discussions. I mean that's why we have people other than me in the public affairs office, because they do a fantastic job.
I agree with what you're saying, and the problem is that with the general public and in Washington, facts are negotiable, perceptions aren't. It's hard to change those perceptions.
Well, that said, the protests at launches of spacecraft that have nuclear components have been decreasing in size and in frequency. So there's something, maybe when you do it regularly, it's not as worrying. I don't know.
Well, that and they've lost every court battle that they've entrained. And so, you know, losing is the opposite of winning, okay? So if they won something occasionally, why, they'd probably be more motivated. But they're 0 for X, where X is a fairly large number at this point. And I mean, they protested everything, not just the launch, they protested flybys, you know, they protested on behalf of the non-existent Martians, you know, I mean, there's any number of things that you can protest, but after a while you have to have something in the win column.
Okay, moving right along, we had heard about lots of technologies. For example, just in the field of propulsion, we had one speaker talking about all of the volatiles you could get for chemical propulsion, and others saying that the nuclear thermal propulsion is wonderful, and nuclear electric propulsion from someone else, and then photonic propulsion from someone else. To what, in the next decade, how should we be moving? Should we be moving forward on all fronts? Can we assign different roles for different propulsion types based on their speed and how fast they can move a given mass? You know, for example, a supply ship could go to Mars much slower than a manned vessel. How would you all put that technology together, and where would you put your emphasis?
Well, I prefer warp drive myself, but is anybody from Star Trek here? I would, you know, okay.
Yeah.
Oh,
Yeah,
gee, so, okay. You know, it turns out you really can't take as long as you want. I mean, orbital mechanics, going from here to Mars, you actually have to go fast enough to match the orbit of Mars in a home and transfer. If you go slower than that, you never reach Mars, okay? So there, even with cargo, there's sort of a minimum speed that you have to achieve. And I guess the trans-Mars injection is like 3.5 kilometers per second, or something like that, for a home and transfer. Now, if you want to go faster, I always put it this way. If you got a lot of go power, you need a lot of whoa power. Because the faster you go, when you get to Mars, you are not on a tangential zero velocity intercept. You are coming in at an angle, and your relative velocity is very high. So the faster you go, you've got to be able to slow down in order to get into orbit, or you'll just sail on past Jupiter, Saturn. It's a very long trip, you know. So you really need a propulsive efficiency. What you'd like to have is a propulsive efficiency of the characteristic velocity of the solar system, which is 56.8 kilometers per second. That's escape velocity from the solar system. If you have that, you can maneuver in the solar system with impunity. And so what sorts of propulsion systems do that? Well, electric propulsion system does that. Nuclear thermal propulsion is part way there, which means you can explore the solar system with impunity part way. But then you run into an issue of acceleration and travel time. And it turns out that for equal thrust, the power is linear with ISP. So if you want to match something like a chemical rocket, how many kilowatts of power does the Saturn V produce, or did the Saturn V produce? A couple of gigawatts. You want to accelerate fast? If you have high ISP, you need lots of power. It's just physics, folks. And 56 kilometers a second is 5,500 seconds ISP. And 55 kilometers per second is 5.5 times 10 to the fourth squared joules per kilogram. That's 550, 55 square, or 5.5 squared hundreds of megajoules per kilogram of propellant. So the thrust goes down linearly at equal power with ISP, but for a constant thrust, you need to increase your power linear. It gets big fast. Anybody else have a comment?
Sure. I think the question I thought was asked, well, I think there's a difference between nuclear thermal and nuclear electric. Nuclear electric makes perfect sense for sending cargo or things that can go slow. But it turns out it probably makes more sense now for human payloads because there's a question of testing. This is not the 1960s. Can you test a nuclear thermal rocket anymore?
Sure. We know how to do it. We knew how to do it in the Timberwind program. Okay, if we hadn't traded it for the Russians, we'd be flying the doggone thing, okay?
But there are, I mean, the public reaction is going to be huge on that.
Okay, I'm going to tell you about public reaction. We had states fighting over whether they would have the right to test our rocket engine in their state. Even states that had no existing site-wide EIS, namely Utah, was saying, wait a minute, you're going to test that nuclear? We want it. Okay? Mike was talking about public relations. You know, a good program manager has to be sort of part Phineas T. Barnum, okay? And I'm not saying that in a pejorative fashion. If you've got a good product, you have to know how to sell it, okay?
Like cigarettes?
Well, I mean, there are still people that smoke. Somebody's doing a good job, okay? You know,
Just saying,
I mean, I don't
perceptions have
smoke. I
changed.
never have. And by the way, pardon me, don't take this personally. I resent you calling my neutrons equivalent to cigarettes, okay? My neutrons are very healthy neutrons, okay? And they're very healthful neutrons. If you had a few more of them, you'd live longer. And that's a proven fact, too. See, now, I told you I was the entertainment, right?
I think Philip had an answer.
I don't know if it's an answer, but I think part of the issue is, what do we want to do? What is the goal here? And I think what we're lacking, is September 12th, 1962, which said our goal is to go to the moon and return a human back safely. We don't have a goal at the moment. This is the TVIW, it's the Tennessee Valley Interstellar Workshop. There's been very little interstellar discussion here, with the perhaps exception of my own talk. And I think a lot of this is, what do you guys want to do? And I think this is a real lack of leadership. It's not a blame, but when there is a national will or an international will, there will be an international way. Just as we're sitting on a site which went from 0 to the end in 18 months. When there was a national will, we did it. There's not a national will at the moment. And that's a very sad commentary on where we are. So we hold workshop after workshop after workshop, and we come away with the same, well, I don't know, what do you want to do? And I think we should set a goal. I thought Culberson said this well, let's try to get to a star 100 years after the moon landing. That was an aspirational goal. That would inspire the next generation, inspire the public. Can we do it? It looks like we could on paper. Could we pull it off technologically? Well, there's a lot of technological issues that we have to face. And I think we need some sort of aspirational goal so that we stop fighting about, whose pet rock is the most beautiful pet rock, and we have a goal in mind that we can rally around and do it.
And building on that, I know everybody's been having good side conversations and side meetings, and so I'll just give you the ones I've been in, which you can guess involve nuclear thermal propulsion. But one of the things we have been talking about is, given the theme of the power of synergy, is could I use an NTP for a lot of the missions that NTP is well suited for, but use an NTP-derived system to provide electricity for nuclear electric propulsion, or provide power for a laser to drive a laser satellite. And so again, just in that one area, we see a lot of synergy where you could have, again, from my knothole, you develop the nuclear thermal rocket, but you have derivatives of that NTP system that can be applied to all these other technologies. And I keep saying from my perspective, because there's a lot of people here, and I'm sure you've been having the same conversations from your perspective, but I think one of the benefits of this workshop is that we can hopefully come up with some synergies, where we really can say, okay, let's all generally support this. I mean, I'm even going to support lasers now. So but just begin, because it moves everything forward. So.
Well, in that case, since we are about to head into the transformative decadal plan, theme 3, let's expand on what Phil just said about having a goal of some kind. Now, fortunately, I think whereas previously things like the Manhattan Project and the Apollo program were largely political goals of a fairly short and defined nature, now we have corporations getting on board and wanting to do things. And as Jason pointed out just before the break, there's all kinds of benefits of industrialization in space and so on. So if I was the busy politician hearing your pitch for 30 seconds while I'm on my way to a vote or something like that, in maybe one word or one sentence, why should we do any of this? Why should we invest in space? Why should anybody? Roger?
Well, I think the answer to that question is partially self-evident in the commercial world. You have Elon Musk investing a sizable fraction of his own personal fortune to get to space, and he has this grand vision of 1 million people on Mars by sometime this century.
Time's up.
Pardon?
The congressman needs to get to his vote.
Just a second. What I'm trying to say is that the whole idea of what goes on in space is radically changing, okay? Jeff Bezos is investing $1 billion plus a year. And so the point I'm trying to make is the landscape on how we get to space, who has access to space, is radically going to change. And candidly, the idea of a transformative vision, the transformative vision in access to space has already taken place. People are actually privately going to space. What do you tell a congressman? You say, the nation needs to take this next step. You've already been successful. You have a win. You have commercial companies willing to spend their own money to get into space. You have to provide the stepping stone to work and operate in space. If you don't develop the necessary technical capability, it isn't going to happen. That's the job of the government. And so I think actually the government's been very successful in getting us to the next tier where commercial industry is actually willing to invest their own money to go to space. Now they need to have the technical base to take the next step. That's my opinion.
I agree.
Cowabunga.
Cowabunga. The truth is there are enough people on this planet that are sufficiently wealthy that they can afford to go into space on Jeff Bezos or anybody else's mission. You know, if you want to charge $1 million to go into space, there are lots of people that can support that industry. And I think that will happen. And what you have to ask our congressional people or Washington in general is, do you want the United States to take the lead, or do you want the Europeans or the Chinese to do it?
Okay, that's a good sell right there.
That's the Space Force. Should we talk about the Space Force? No. Oh.
Now, okay, again, one word or one sentence.
Great nations explore.
Great nations explore.
So, from my point of view, I think everyone in this room was likely inspired by either the footage of the Apollo program or perhaps some of us, like myself, are old enough to remember it. Give people a dream, and they will follow the dream with you. Give them something which is more of the same, and they will walk away from you. So if you want something which is an accomplishable dream, look ahead and see what could we do in the next 50 to 100 years, and then pursue that dream and look at the logical consequences of it and see where does it take you. In the dream that we've put forward, the consequences are transformative. You can get to Mars in a month. You can literally, if you push it forward, you can get to Mars in 3 days. And those are the kind of aspirations that people can rally around, not the Mars part, but the ability to get beyond our solar system into another solar system. It's that which allows children to dream that it's not just more of the same, that you can do something truly magnificent in life. And when you do that, then you have a way forward. Without it, you don't.
Yeah, I would just say I think it's a combination of the excitement of being able to explore the unknown that motivates people, but also just to maintain leadership. If a country wants to maintain leadership, it has to be at the cutting edge. You know, we can't be just leading in miscellaneous areas, and space exploration is definitely at the cutting edge.
Ken, do you have something? Go ahead.
Yeah, just a thought that in space, one reason to go there is there's tremendous energy and material resources, and the country that controls space, not only has access to those resources, but space has also been described as the ultimate high ground. So you've got an element of national strategy in here that needs to be thought about. Do we control our destiny, or do we let someone else control our destiny?
All right, I'm going to close this with a quote from the Rice University speech delivered on September 12th, 1962. It says, "We set sail on this new sea because there is new knowledge to be gained and new rights to be won, and they must be won and used for the progress of all people. For space science, like nuclear science and all technology, has no conscience of its own. Whether it will become a force for good or ill depends on man, and only if the United States occupies a position of preeminence can we help decide whether this new ocean will be a sea of peace or a new terrifying theater of war. I do not say that we should or will go unprotected against the hostile misuse of space any more than we go unprotected against the hostile use of land or sea, but I do say that space can be explored and mastered without feeding the fires of war, without repeating the mistakes that man has made in extending his writ around this globe of ours. There is no strife, no prejudice, no national conflict in outer space as yet. Its hazards are hostile to us all. Its conquest deserves the best of all mankind, and its opportunity for peaceful cooperation may never come again. But why? Some say the moon. Why choose this as our goal? And they may well ask, why climb the highest mountain? Why fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon in this decade and do the other things not because they are easy, but because they are hard, because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one we are willing to accept, one we are unwilling to postpone, and one we intend to win. Thank you.